Okay, the neat thing about parabolas is that they're symmetrical. Symmetrical means same on both sides. They're a mirror image of each other. And there's been lots of studies done that in everything, humans, that the things that we find very beautiful or attractive usually have high degrees of symmetry. So if you do symmetry on like supermodel faces and things like that, they tend to be very symmetrical. If you did it on my face, my left ear is bigger than my right ear. I'm definitely not in the supermodel category, so I have to go into math. So we just deal with what we're dealt. So I call these beautiful because they are perfectly symmetrical. So there's a mirror in them. So one side, if I folded this parabola in half, it would be exactly the same. It will lay along the exact same line. Okay? So it is symmetrical. It's beautiful. If you look at this graph right here, this is the line of symmetry. This is your mirror. So if I took this graph and I folded it along this line, all this side will match directly up with this side. They'll lay directly on top of each other. Okay? So that's the symmetry. Each parabola has a vertex. So the vertex is like what I call it a turning point. It's like you're going up, 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 up. You hit the vertex, and now you're going down, 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 down. Okay? So I call that the turning point, the vertex. And it's always listed as a coordinate pair. You guys know in coordinate pairs that x comes first, y comes second, right? Yes? Now these are your notes, ladies and gentlemen. I will never ever look at them. I give you as much type stuff, like I said, I can bother to read it myself. I don't know if you'll bother to read it, but your notes should make sense to you. So what you write down or what I write down here doesn't have to be exactly the same what you write down. So don't feel that you have to copy absolutely everything that I do, but make notes as it makes sense to you. Okay? Because I'm guessing all of you are going to go on to post-secondary at some point, whether that be a trade or whether that be university or whether that be a college. You're going to be in classes with professors, instructors of some kind that are going to want you to take notes in some format. You've got to make them valuable to you, not to the person sitting next to you. So write down things that make sense to you. I like to use color, that's my thing. A parabola will have a minimum value if it opens up. So this graph, this little graph here, that opens up, so the two arms are pointing out, it has a minimum value because it goes down, 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 hits its absolute minimum, and makes the turning pounds all the way back up. So it only goes down to a certain point. So if your graph is opening up, you have a minimum value. If it's opening down, if the parabola is opening down, like this one here, it goes all the way to its max point. It will never exceed this max point, and then it's coming down. So if you are opening down, you're going to have a maximum value. If you're opening up, you're going to have a minimum value. This will make sense the more we graph them. And the y value of the vertex is either the max or min. So looking at this graph that I've given you right here, I don't know if you guys can see that, is this graph a max or a min? Does it have a max or a min? Max, right? So looking down, it hits a max. What's the maximum of this graph? 120. So I look to my vertex. The vertex is at 8 and 120. So the 120 represents my max value. Can you have a max and a min on one quadratic graph? No. Where am I at? Where am I at? Now you can only have one. Okay, how do you feel about that? Nothing terrible yet? Okay, no crying, this is good. Each parabola is symmetrical, we talked about that. It has a line of symmetry. Now, it has to be an equation, has to be given to me in an equation. And so the equation is the x-coordinate of the vertex. So we'll go back up to this graph. My line of symmetry, so you guys remember this from grade 9? Of course you do. Of course you do. Vertical lines, the equation of a vertical line starts with an x equals, like x equals 2, x equals 7, right? There's no other variable in it, it's a single variable. So if it's up and down, it's an x equals some constant. If it's vertical, it's y equals some constant. Your lines of symmetry will always be these ones. They're always going to be verticals. We're not going to do a parabola line on the side. That's something different. That's a hyperbola, and the lay on the side, but we don't do those, not until calculus. I know you're super pumped I'll get to calculus. So you're always going to give it in the equation. X equals whatever the x coordinate of the vertex is. So all the information's there if you're looking at the graph. You just need to know how to pull it out. Nothing secret. So the equation of this axis of symmetry is going to be x equals 8. I think that's already on the graph. I just can't see it. All right. So you can graph quadratics using a table of values, a formula, or you can use technology. FYI, ladies and gentlemen, you will not be using graph calculators. You're not allowed to use them on the provincial exam in grade 12, so we're not going to use them here. I'm not going to give you teach you how to use it and then take it away from you on your exam. That's kind of cool. So we're not going to use it at all. So technology, I use my graphing calculator all the time, but I don't have to write the provincial exam. So for each graph we're going to do today, we're going to list this beside. You're going to tell me what the vertex is. You're going to tell me the equation. So it has to be written as an equation. What's the most important thing in an equation?
Equal sign.
Thanks, an equal sign. Don't read that. That makes me sad when people say the axis of symmetry is at 8. They just write the number 8, and that's incorrect. It has to be x equals 8. Okay, so that makes sense, everybody? Ooh, domain and range. You guys remember that? It was like, kind of. X-intercepts, so where it crosses the x-axis. Direction of the opening, this one's really easy. You guys see if it opens up or opens down, the toughest one. And then what the max spin is. Okay, so here we go. Let's graph. All right, this is the most perfect graph, and I think we'll start with the table of values because that's going to be the most helpful, I think. All right, so table of values. I pick my x's. I pick them. All right, so I'm going to pick, these are the ones I always pick, -2, -1, 0, 1, 2. That's exciting. All right, so now I got to figure out what the y values are. Now my equation is y equals x squared. So if x is -2, I'm going to substitute that into this equation. So that would be y equals -2 squared. 4. All right, so if I substituted -1 into that equation, 1. 1 squared is 1. 1 times -1 times -1 is 1. 0 squared. 0. You guys feel smart yet? Come on. You can square things, you're good. 1 squared? 1. And 2 squared? 4. Look at you guys. Brilliant. Okay, so now we're going to plot those points. Okay? So I have -2 and +4. I have -1 and +1. What's your scale on these? 0, 0, +1 and +1, 2 and 4. So I'm going to connect those with a smooth curve. It should not look like a V. Do not make it a V, because then you've done an absolute value graph, which is correct. So it should be a nice smooth curve. All right. Are we smarter? I think we are. I think we're smarter than when we walked in. Okay, what's my vertex? What's my turning point at this graph? 0, 0. Remember, the vertex is always given as a coordinate pair. 0, 0. Okay, axis of symmetry, I want you to give it to me as an equation. X equals 0. Because it is the x coordinate of the vertex. The x coordinate of the vertex is 0. And if I drew a line right down x equals 0, that's going to be the near. Notice I drew it as a dashed line. So what that indicates to you or indicates to me is that line actually doesn't exist on the graph. It's just a helping line or something that's going to help me graph. We do those a lot when we're graphing sinusoidal functions. You can put those in if you want to. We put those in for our asymptotes, which you don't know yet, but it'll get better. Let's jump to x-intercepts. So where does this graph touch across the x-axis? There's only one. It happens at 0. It touches it at x equals 0. Okay, opening. Does it open up or does it open down? Okay, that was the hard question. Okay, so if it opens up, do I have a max or a min? I have a min. And where does that min occur? 0. Because it's the y value of the vertex. Okay, so you're smarter than you were 2 minutes ago, and now we're going to do the domain range. The domain are all your possible x values. And notice my graph has arrows on it, so that means it continues. So where am I going on the x-axis? Now my table only goes from -2 to +2, but with those arrows I could graph other things, right? So if it goes on forever, I'm getting wider and wider and wider. Will that ever stop? No. So what's my domain? If I go on from ever and ever and ever. Yeah. So when we're doing domains, we always put the lower limit on the left-hand side. Lower on the left. So my lowest limit will be -infinity. And my highest limit on the x-axis will be +infinity. Oh, that was a bad infinity. Round brackets on both of those because we never actually reach infinity. It's not included in my values. Or, you fancy people, you could write x is an element of the real numbers. No, it's only different. Okay. X is XER. X is an element of the real numbers. Real numbers are all the numbers. And guess what infinity is? All the numbers. So it's just a way of saying it, and the E has to be like a C with a line to it. It's not like a capital E. It's weird. So draw C, okay, and then put a line to it. It's not just my bad printing, which is very well could be, but this one, elements, this means in that element. Capital R usually has a fancy 2 lines on the R. That you don't have to. If you just put a single R, that's fine as well. Okay, so X is an element of all real numbers. R stands for real numbers, and that's every number, and that's what infinity is on. You can give it to me in either way. Okay? Feel smarter? Perfect. Okay, range. The range is how low to how high. So what's my lowest point on this graph? 0. Does the graph include 0? Yeah, it's a point, right? Like, we actually graphed it. So my lowest point is a square bracket and a 0 because it includes that point. Is this coming back to you from grade 10? Nobody likes going and reading grade 10. And then by the time you get done grade 11 and grade 12, it's like, it was so easy. That's what I say, like, by the time you're done this course, you're going to say, you remember when domain and range was hard, and you're going to be like, oh yeah, that was hard. Now something else is hard. Domain and range is easy. So where am I going maximum ones? Infinite. So positive infinity, and I have a round bracket around that one. Okay? Because infinity we never reach, it's a concept, it's not a destination. All right, how do you feel about that? Nothing too terribly difficult? All right, moving on. Okay, so now we're going to do another table of values. I'm a big fan of -2, -1, 0, 1, 2. You can pick other numbers, but just be careful of your increments on your axis. Okay, I've given them to you, so I'm going to try to keep things within that. Okay, so now my equation has a 2 in front of the x squared. So this is going to be y equals 2 times -2 squared. So what do we do first? Square. We deal with the exponents first, right? So -2 squared is 4, and then times 2 is 8. Positive 8. Okay, so now if I put the -1 in there, I'm going to square the -1 first, which gives me 1, times it by 2, 2. 0. Do you notice anything about your y values? Anybody notice anything? They're kind of all the same, right? Like so you'll get better at this where you don't have to do all the calculations. Now this one's not perfect. But we will get into a little bit more complicated ones. Okay, so let's graph this. Again, it should be connected with a smooth curve. Okay, so what's the vertex? 0, what? 0, 0. It's always a coordinate pair. What's my axis of symmetry? X equals 0. Domain for this one. Negative infinity to positive infinity, both with round brackets. Nobody bought into the XDR, okay? All right. Range. And don't forget, it's inclusive of the 0, so we're going to put a square bracket around the 0 and a round bracket around the infinity. Do you guys remember this? Yeah. Are you okay? Oh, that's great. Like, we kicked you. Okay. X intercept? 0. Opening up. And is it a max or a min? Min, and the min occurs at 0. See? So much better than you were 2 seconds ago. Easy peasy, right? Nothing terrible. Okay, so. Oh, can I go back here for a sec? Okay, I want you to look at your 2 graphs. Your red graph, or my red graph, and your blue graph. Okay, same scale, same coordinate plane that they're put on. What do you notice about the 2 graphs? Like, talk about what you see as the visual difference between these. Because this looks pretty much the same, don't you think? Like the vertex and everything like that. All the stuff that I've asked you about looks exactly the same. What do you notice about the difference between these two graphs? Okay, one's wider, one's skinnier, right? I'm going to not use the word steep. The only reason why is because these are curved lines, okay? And we do steepness of straight lines. So you guys are, that's good because you're understanding slope, you're understanding that. And if you get to grade 12 calculus, we'll do slopes of curved lines. It's very fun. So this one is this one's wider than this one, right? Okay, keep that in the back of your head. Okay, moving on. We're going to graph this one. All right. So I'm going to pick -2, -1, 0, 1, 2. I'm pretty predictable that way. So now I'm going to have, so what am I going to do first? I'm going to square it. So I've got +4. +4 times by a half is 2. So -1 squared is +1. +1 times a half is a half. 0? 0. Okay, without doing any math, what do you predict the rest of the table is going to look like? A half and 2, right? Because a half 2 is it's symmetrical, right? Now, I'm going to make a spoiler alert here. Not all vertexes occur at 0, 0. Okay, so your vertex moves on the coordinate plane. In these ones, it's kind of nice because we're just starting. So I'm going to graph this to -2 and 2, 1. Ooh, let's add another one in here just for funsies. So we see another point. Let's add in -3 and +3. 4.5. 4.5, right? So if I'm at -3, well, let's do +3 because I can continue my table. Right? So 3 squared is 9. 9 times by a half is, what's half of 9? 4.5, right? So if I go to 3, 4.5. So I'm in -3 is also going to be 4.5. Okay. Not my best graph there, but you get the idea. And again, it should be connected with curved lines. The reason why this can't be these is that's a different type of graph. And if we were to graph every point in between, if we were to use technology, you'd see that it comes up with this smooth curve. I'm not going to ask you to graph every decimal in between 0 and 1. That would be painful, but our technology can do it for us pretty quickly. So you end up with this nice smooth curved line. A V-shaped graph is an absolute value graph, and we're doing those in chapter 7. I see that with like 95% certainty. Okay, can you guys fill out the side column? Yeah. Okay. Okay, so if you filled out the side, check to see if you got the same answers as me. If you're continuing to fill out the side, make sure you do that. All right. Okay. So if you look at your first graph, you're second graph and your third graph, if you looked at all three of those, what do you notice the differences about them? Because there's no difference in the tables, right? All this stuff is the same. What did we say was happening? Why they're skinny. Okay. All right. So what did we notice? We noticed that if there is a value in front of the x squared, that's going to control the width of the graph. Okay, obviously I can't write in boxes. I have a huge box and then it's really nice and put stuff in it. Perfect. I ran off the side. Okay, so what does what? So you had one that had a 2 in front of it, and then you had one that had a fraction in front of it. Which one's the skinniest graph out of all three? The one with the 2. Okay, which one's your widest graph? The half, right? Okay. So if A is greater than 1, you guys know what I mean by A? Like it's just the number in front. Okay. I made a statement there that I didn't talk about it. So if A is greater than 1, so that's like our 2 graph, what do we notice? It's going to be what? It's going to be skinnier, right? Okay, technical math term, narrow. Skinnier, that's, I don't know, for me visually that makes more sense. Okay, so now if it's a fraction, what do we know about the graph? Wider. Okay, so I'm going to make a statement about that. So A has to be less than 1, right? Because that's a fraction less than 1. But it has to be greater than 0. I find students have a really hard time reading restrictions. And that's what this is called. I'm saying A has to be a set of numbers. So all this means is A has to be between 0 and 1. So that's the English part. That's what the math part looks like. We're going to do more of these restrictions as we go on, like just so that we get used to them. And we know that if it's a fraction, the graph will be wider. Okay, so those are things that you got to remember. Don't get the tattoo. This is not important. Well, it is important, but I think you can remember this. Okay, we're not going to use the graphing calculator. Sorry, that should be deleted there. This is the second year, that we're not teaching with the graphing calculator. And I missed it. All right, okay, so we're going to graph this one now. I'm still going to use, I don't know what I did. I got to really dig out there. All right. Someday I'll figure it out. Again, very predictable, -1, or -2, -1, 0, 1, 2. So now when I substitute it in, we're still going to deal with our exponents first. So there's nothing to multiply it by. So -2 squared is 4, and then I'm going to add 4 to it. 8. -1 squared is 1 plus 4, 1, 5. Okay, 1 times 1 is often 2. It happens. 0, 4. 4. And if you were to hedge your bet, what do you think is going to happen? 5, and then 8. Okay, so let's graph this. Are we good with graph? I graph them really fast, and then I'm like, okay, let's see what we know. So if I'm going too fast, sometimes I can slow it down, sometimes I can't. Are we all graph? Do we all feel confident for graphing? Okay, so our vertex, 0 and 4 this time. So again, our vertex now is shifted. It was what used to be a 0, 0. Now it's at that. Okay, so axis of symmetry. You only have two options, and I didn't break 4 down. X equals 0. Remember, it's the x coordinate. It's the x coordinate of your vertex. Okay? The equation has x in it, and it's the x coordinate. Domain. Right, negative infinity, positive infinity. Okay. The infinity signs are getting better. The range for this one. Right. So square bracket around my 4. Positive infinity with the round bracket. X-intercepts. Where does it cross the x-axis? Who's ever saying it doesn't is completely correct. So we're looking at our x-axis here, okay? And that graph doesn't touch it at all. It's not going to touch it. The graph's going to keep going up and up and up. It's not going to cross the x-axis. So here's the deal with this, is you have to write the word none. You have to write that. Because if you don't, I don't know if you understand that there's none or if you skip the question. Does that make sense? So you have to indicate to me, like, by leaving something blank, that's an automatic, like, you skip the question. So you have to read in there, oh, there's none. I get that, there's none. The opening is hopefully still up, so that means we have a minimum, and the minimum occurs at 4. All right, we feel smarter. Yay, okay, perfect. That's what I like to hear. Oh my God, we're going to be graphing for days. Days. Pardon? Oh, of course. Of course it does. Okay, let's graph this one. Oh, I want to use this for color, but I didn't need to switch pages. -2, -1, 0, 1, 2. Okay. Oh, excuse me. What's my y value here? So -2 squared is 4, but now I'm subtracting 1. You sure? So -1. If you can't tell the vertex from here, there's a lot of 1s and there's a lot of 0s, and you know it's somewhere around there, but which one? Just graph it and let the graph tell you. Like, trust your math. Okay, you guys can fill out the chart because I have faith that you've got the hang of this now. Okay, so this one a little bit different. Now the charts aren't looking the same. Now my vertex is different. My range is different. My intercepts are different. My minimum is different. Like now, all of a sudden, I'm getting different numbers. Bless you. All right, so what did we notice? So if I have the equation y equals x squared, okay, I'm just debating on my variable. So if I add or subtract something to the end, what did you notice what happens to the graph? If I added something, where did it go? Well, the first graph I added something. I added 4 to the first graph. So where did my graph go? Went above, right? Went above the x-axis. When I subtracted something, went below. So what are we going to call that? Okay. And in math, we call that a vertical shift. Because vertical is up, down, so we're moving it up, down. So if it's a positive k, it's going to move it up. If it's a subtracting by k, it's going to move it down. Yeah. Oh, yeah. That makes sense to everybody? Okay, perfect. All right. Okay, we got 3 graphs left to go, and I think we can do this. All right, I need to switch colors. More color than purple. All right, so if I substitute this one in, so order of operations tells me to do what first? Do the inside of the brackets first. So -2 subtract 1. -3. -3 squared is 9. Okay, so a little bit more of a thinking question. So now I put a -1 in there. So -1 subtract 1. So -2 squared is 4. If I put 0 in there, if I put 1 in there,
4.
No. Now we gotta actually trust our math because I'm not sure where my vertex is. So if I put a +1 in there, +1 minus 1. 0, 0 squared is 0. If I put a 2 in there, 1. 1 squared is 1. Okay, graph this. get that. I get a check mark. Okay, so what this has told me is that my favorite, negative 2 to positive 2, isn't telling me the whole story. So I don't know, this is just me. I want to have it symmetrical. I want to have as many points on the left side as I do the right side. Can you guys identify the vertex on this? So my vertex is, got that backwards, 1 and 0, right? So I've got this point, I need this point, and I need that point. So I need 2 more points, so I'm going to add 3 and 4 on here. So if I put 3 in there, it's going to be 2 in the brackets. 2 squared is 4. I don't really have to do math because I've identified this as my vertex, right? What am I adding? I added some on so I can get the rest, so I can get the other arm of my parabola. I'd like you to. There will be times when the table of value you picked doesn't show you your vertex. You get that. And you're like, well, that's not a U, right? So sometimes we have to pick more once we've started. So you can have the U. It's not, I can't say 10 points will always give you the vertex. It really depends on what you pick. Don't worry, we will get better at this, and I'll show you more difficult equation marks. Okay, axis of symmetry in this one. X equals 1. Domain, negative infinity, positive infinity, range. 0 to infinity. Remember, we're looking at the y, right? So we're looking at how low the y goes. X-intercept. Nothing's at 1. Opening is up. We have a minimum of 0. All right. Okay. One more. 2 more. So 1 more for this section. I'm trying to make it better. All right, so I'm going to pick my table of values. I got negative 2, negative 1, 0, 1, 2. Okay, I'm going to ruin the fun for you for a second. Okay, just do it like that. Just do it like that. Move your negative 2 down a little bit. All right, so if I put negative 2 in here, so y equals negative 2 plus 2 squared, I get 0. If I put negative 1 in there, okay, if I put a 0 in there, if I put a 1 in there, okay, so if I graph that, I'm going to because that seems like the fun thing to do. Yeah, you should graph it. I can't graph that 16. You see my problem? Do I have a U? Do I have a parabola shape? So I got to keep going. It makes no sense to keep going on the positive because I couldn't even graph the 16, right? I'm already off the graph. I know that another point is just going to put it further up here. So that means I got to put some more values in the negative. That's why I asked you to leave a little bit of space. Okay, so what's my next value that I'm going to graph? Negative 3. So negative 3 plus 2 is a negative 1. Negative 1 squared is positive 1. What do you notice right away with my y values? Looks like that might be my vertex. So let's do -4 just for funsies. So -4 plus 2. It's -2. -2 squared is +4, which we could have predicted with that, right? All right, so I got the other side of my U. Not all the points, but what would you predict -5 is after without calculating anything? Probably your 9, right? Because that's the y value that came here. And remember, it's symmetrical. All right, so my vertex occurs at -2 and 0. My axis of symmetry is x equals -2. My domain, -infinity, +infinity. My range, 0, +infinity. My x-intercept occurs at -2. I open up. So that means I have a minimum. Okay, so this is the more tricky one. All right. All right, so if I have x subtract h, so if I have that, like so h equals some number, what did you notice? So that would have been the first graph that we did. What did you notice? So when I was subtracting 1, what did you notice about the graph? Didn't go down, it went horizontal, which way, left or right?
Right.
Right. All right, so if x minus h is in the brackets, it shifts right. Isn't that confusing though? Because if it was a negative, shouldn't it be going the other way? X never tells you the straight story. X always does opposite to what you think. Why? Honest, good. X is a little bit sketchy. So if you have x plus h squared, which way am I going? One of those, yes. But if it's, you'd think if it was add, it should be going that. Anyway, whatever. This is called a horizontal shift because it's going left or right. Sometimes it's also called a phase shift. Just FYI. Anybody else notice anything? Nope, not well. The graph here, you might not, but that depends on how many points I graph. If I graph one more point, my graph would be beautiful. Okay, I just didn't make it beautiful. No judgment here, though, right? Judgment, no. Anybody notice anything else? Okay, we'll get to that later. That's not the most important thing. This is going to be the tricky one where it shifts opposite when it's inside the bracket. Okay, last one. Last one, we've got this. You're all like, can I stop graphing now, please? All right, so I have -2 and go back to -2, -1, 0, 1, 2. I'm not going to do a weird table or anything like that. So in this, because that negative is not included inside the bracket, this is how it would look. Y equals negative bracket -2 squared. So -2 squared is +4, but then you're multiplying it by a -1, so it's going to be -4. What's my next one going to be? -1. What's my next one going to be? Hopefully 0. 0 can't be positive. Well, 0 can't be negative. Let's go with that. -1. -4. Okay, so let's grab that. Hey, that's exciting. No, I'm excited. The first one I did that. Thank you. Appreciate that. So my vertex, 0, 0, axis of symmetry, x equals 0, my domain, -infinity to +infinity, my range. Ooh, I got excited there. What's my range? What's my lowest limit? -infinity. What's my highest limit? U. So that's switch. My x-intercept is going to be at 0. This time I'm opening down. So I'm going to have a maximum. And my maximum's at 0. So what do you notice controls the opening? The sign in front of the x squared. So if we went way back to the first one that we did, the A, if it's positive, it's going to open up. If it's negative, it's going to open down. Okay, so that was long.